Good morning, students. So today's session is for another program, another problem. Simplify the following grammar. Okay, that is the problem of simplification of context-free grammar. A set of context-free grammar has given us input. Okay, so we are going to simplify this grammar. Okay. So how many steps are involved in the simplification of context-free grammar? How many steps are involved in the simplification of context-free grammar? Post in the chat box. Yes, very good. 3 steps. Okay, so number of steps, 3. Actually, it has some order. Okay, so the last day session, so one point is added in the last end of the notes, that is note. So a safest order for applying the 3 steps in the process of simplifying context of the grammar. Okay. So what is the first step? Number 1. Step number 1 for simplification of context of the grammar. What's the step number 1? Null, unit, useless. Very good. Yes. First thing, eliminate null productions. Second thing, eliminate any unit productions. Third, eliminate useless symbols. Okay. And this is the safest order. Okay. So removal of useless symbols. Keep it as this as the last step. Okay. Okay. It's the solution. Step number 1. Eliminate null productions. That is epsilon productions. So in this grammar, actually the direct null productions. Okay. So the direct null production, which is a D gives epsilon. Okay. So this is the direct null production. So as D produce epsilon, okay, so as D produce epsilon, what about B? B also produced epsilon indirectly. Okay, B is produced null string in direct mode. Okay, and as B is produced null, B is indirectly produced null because B gives D. Okay, so D gives epsilon. This is the direct nullable. Okay. This is called directly nullable. Next, B gives epsilon. Okay, so which is indirectly nullable. So indirectly nullable. So is there any other production which is added in the indirectly nullable? I think no. Okay, as B is the only one production to produce D directly. Okay, so some other productions are combinations. Next, how to remove these null productions? Okay. So the resulting grammar. Okay, first, in this the resulting grammar. This is the resulting grammar after eliminating the null production. First one. Yes, produced actually 2 productions, A, B, C, B, A, B. Okay. C, B, which is produced indirectly a null, right? So in the place of B, so I will replace B with epsilon. Okay. So see, keep it in your mind. For the process of eliminate null productions as well as eliminate unit productions, some more productions are added to the existing productions. Okay. So I will write it A, B, C and B, A, B as it is. I will write it same A, B, C, okay, and B, A, B. Existing production. Along with existing production, some productions are added and as additional. Okay. So in the place of B, I will replace epsilon. Okay, if I put epsilon in the place of B in the first production means it will give AC. ABC becomes AC, right? Next, here, second production, BAB. So in the place of first B, if I put epsilon means, what's the remaining production? AB, right? AB. In the place of the last B, if I put epsilon means, what's the remaining production? BA, right? Then in the place of both, in the place of, so I will replace epsilon, okay, for both B means the remaining production, which is A only, okay. Okay, this is the actual method. So the productions for S, which is over. Next, A production. A gives AA, BAC, triple A. Okay. So I will write all the three productions as it is. That is AA, then BAC, then triple A. So the first production AA, there is no any productions like B and D. So leave it. In the second production B is there. In the place of B, I will replace B with epsilon means what is the remaining result? AC. Okay, that's it. So A production is also over. Next, C production, B production. B gives B, 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 A, B. Okay. So I will write all the productions as it is. B, 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 then A, then D. Okay. See, in the place of B, if I put epsilon means B, B, B will becomes B, B, right? Okay. So in the place of D, I will put epsilon means epsilon only. So no need to add that epsilon. Okay. So B productions also over. Next, C production. C produce CAAC. I will write the productions as it is. C produced CA and AC. Okay, so there is no any productions B and D. Okay, that is not added in the C productions. Okay, so leave as it is. Next, D gives epsilon. Okay, this production is automatically removed. Okay, because this is the step of removing null production. Okay, so this is the resulting grammar after removing the null production. Okay, so the above is the resulting grammar after removing the null production. Okay. So removing null production, the process is over. The next step, okay, remove unit production. Okay. Step number 2. So the step number 2, eliminate unit productions. So eliminate unit productions. So here, this is the resulting grammar. Okay, so this is the resulting grammar. Here, only one production, which is unit production. What is this? The unit productions from this grammar. What are all the unit productions? Post in the chat box. So this is the resulting grammar. So the unit production, which is B, yes, B is the source of the unit production. B gives D. Okay, B gives D, which is the unit production. The unit production which is B gives D. This is the unit production. Okay, so I have to remove the unit production. So what is the step actually I have to, for removing the unit production? In the place of unit production, I can replace the that unit production with its own productions, right? Here in the place of D, so I want to remove a D in the with D's own production, but there is no any productions regarding D, so just I eliminate D. That's enough. Okay, because the D doesn't have any productions. Okay, so I remove D. So I will write so the resulting grammar, which is so after removing unit production, just D is eliminated. Okay, here the D is just eliminated. D is eliminated. Okay, so we'll write remaining productions. So S gives A B C, then B A B, then A C, then B A, then A B, then A. Okay, so A produced A B A C. Next, triple A, next AC. Then for B production, just removing D. Okay, so remaining productions B, A, B, then A, then B, B. That D production which is removed. Okay, actual procedure is you have to replace any production by its own production, but there is no any own production for D. D doesn't produce anything. So I remove D. Then C gives CA AC. Okay, this is the resulting grammar after removing the unit productions. Okay, next step number 3. Step number 3, which is eliminate useless symbols. Eliminate useless symbols. So eliminate useless symbols means you have to identify the first the useful symbols is in the procedure of what are all the symbols are generating, what are all the symbols are reachable. Okay, this is the way of how to identify the useful symbols from the productions. Okay, if you can able to identify the useful symbols means then the remaining variables or non-terminals automatically removed from the productions. Okay, so this is the steps of identifying useful productions. Okay, first thing, find generating symbols. The first subtopic, find generating symbols. Find generating symbols. See, what do you mean by generating symbols? How to identifying the generating symbols? How to identifying the generating symbols? These symbols are generating something. How to identifying? I'm asking you. Kindly post in the chat box. Yes, which generate a string? Like string means here terminals. Okay. So what are all the non-terminals produced terminals as directly means? Okay. Then those symbols are comes into the generating symbols. Okay. Very good. To find generating symbol, see here the previous uh, grammar. Yes, yes, generating a terminal. A is also generating terminal. B, which is also generating a terminal. Okay, solo terminals. Okay, but C does not produce any terminal. Okay, so yes, A, B. So these are all the generating symbols. Okay. So S is a generating symbol, A is a generating symbol, B is a generating symbol. Yes, A, B. So are generating symbols. Okay. Generating symbols. Y means yes produced A. A produced triple A. This is the way of how to write in your exam. Okay. B produced A. So as SAB produced terminals, these are all the generating symbols, and D does not produce any string. So remove C from the grammar. Okay. C is not produced any string. So remove C from the grammar. So the remaining productions, S gives BAB, AB, BA, then A. I think 4 productions. Yes, C is removed, right? So C is as C is removed. Um, so this production which has the symbol C, and this production which has the symbol C. So I removed C. Okay. Next, A. A production, AA, and 3 times A, triple A. Here, this production which is produced to C, and this production which is also produced to C, so I eliminate these two. Next, B, P, BB, A, then BB. Okay, so these 3 productions. So B does not produce to any C. So finally, I will remove C. Okay, so this is the remaining productions after removing C. Okay, next step, find reachable symbols. Okay, second subtopic in the removal of useless symbols, find reachable symbols. Okay, find a reachable symbols. For to find the reachable symbols, you have to consider starting symbol production. Okay, yes, yes produced, yes produced B. Okay, S produced B, so B is reachable. Okay, is yes produced any A? No, your starting symbol does not produce any A productions. Okay, see these are the 3 terminals. Yes, A, non-terminals. Okay, B, these are the non-terminals. Okay, yes produced B. Okay, so um, from yes you can reach B. From yes you can reach B, but from A you cannot reach yes. Okay, from yes you can reach B because yes produced B, but yes does not produce any A productions. Okay, so A is not reachable. So can remove A. So wherever the A productions are appeared, you can remove. So all A productions are removed. Okay. So the final grammar is the final grammar is yes gives BAB, then AB, then BA, then A. So B gives B, BB, then A, then 2 times B. Okay. So this is your final grammar. So this is the way of how to project in your exams. Okay. It is very easy to write a direct solutions. So from this to the last one, it is very easy to write a direct thing. Okay. You can eliminate the intermediate steps, but from your exam point of view, you should add all these things. Okay. So first eliminate null productions. So what are all the directly nullable, indirectly nullable. So how to remove null, then how to identify the unit production. So this is the form of unit production. Okay, how to remove unit production. Then how to remove useless symbols. Okay, first we have to identify the generating symbols. If any symbol does not generate any terminal means remove those terminal those non-terminals. Then find the reachable symbols. Okay, so this is the final grammar. Okay, so this is almost over. Next, one more problem. Actually, you have to tell me the answer. Okay, so take your notes. So write in the problem. Second problem, simplify the grammar. To simplify the grammar, the productions are yes gives 0 A0, then 1 B1, then BB. I'm asking you people to take your notes and write the productions. A gives C, C which is non-terminal, and B produced yes A, and C produced yes epsilon. Okay. So you have to tell me the answer. The first step, elimination of null productions. So what are the available remaining grammar after removing null? First thing, you have to identify what are all the directly nullable and indirectly nullable productions. Which variable produced direct null? C, yes. So C is directly nullable. So indirectly nullable things are indirectly nullable. Yes, A. A produced C, so A is indirectly nullable. Okay. A produced C, so A is indirectly nullable. So A can gives epsilon. As A gives epsilon, B is also indirectly nullable. Okay, because B gives A, one production is added. As B gives epsilon, one more production like S gives BB, right? The first production, S gives BB. So So yes also produced null in indirect way. Okay. So one direct nullable variable, three indirect nullable variable. Okay. Okay. What are the remaining product? What's the answer of this step number one? Don't leave the meeting. Okay. Yes gives 0 A0, 1 B1, okay, BB, okay, 0 0 1 1 B. Yes, yes, productions are right. Sanjay Charan, uh, as I have already told you, in the say in the case of elimination of null productions as well as unique productions, um, additional productions are added. Okay, so don't remove the existing productions. So you have to include 0 A0, 1 B1, BB. Okay, those productions you have to include. So yes, production which is right. That is, yes gives the resulting productions 0 A0, 1 B1. So I have to write all the productions as it is. BB. Okay. So these are already existing productions. Okay. Along this 0, 0, 1, 1. Okay. See, if in the place of first B, if I put epsilon means remaining one B is added. In the place of second B, I put epsilon means the first B is added, the repeated one. So just add one time is enough. And so if two B's are replaced by epsilon means epsilon, just remove that production. This is yes. Next A gives C, B gives yes or A, C gives yes. Very good. So the remaining productions, A gives C, B gives yes or A, then C gives yes. Okay. So these are all these are all the resulting grammar after removing null productions. Okay. Go ahead. Step number 2. Step number 2. Eliminate unit production. First, identifying the unit production. S gives B, A gives C, B gives S, and B gives A. Yes, unit productions. Okay, what about the result? The result for S. So this is your resulting grammar. Okay, consider the previous resulted grammar. So in the place, so you have to remove B, right? In the place of B, B is replaced by its own productions. See, come to here, the own productions are also unit production. So, see, you can replace the B with S production or A production, which is the right one. If I'm choosing S production means, okay, if I'm choosing S production means the remaining S productions are added, but a repeated one. Okay, but it is repeated one. Then if I'm choosing A means A gives C, C gives yes. So I can choose yes, indirectly yes. So yes, yes replaced by yes productions. Okay, so the repeated one. Okay, so finally, what is the result of yes? Yes gives only 0011. Okay, yes gives. I will add 0A0. This is not a unit production, right? So I will add 1B1. This is also not a unit production. And BB. This is also not a unit production. And 00. This is also not a unit production. 11. This is also not a unit production. B. So in the place of B, I will replace B with its own production. So I will come search for the own production. Those productions are also unit production. So if I choose either, you can replace yes or A, right? Uh, See, if I'm choosing yes, some yeah, valid productions are available. 1 minute. Oh my God. Some valid productions are available, right? 1 minute. So in the place of B, I will choose S productions 0A0, 1B1, BB0011. If I'm writing the thing again means the writing as 0A0, 1B1. So which is repeated one. Okay, this repeated one. So I will eliminate this repeated one because these are already added. Okay, so this is yes production. Okay, so this is actually yes. What is the place of A? A. So A gives C. So you can remove C with its own productions. So C, which is replaced by S productions. Okay, because S only has some valid productions. So what is the result for A? I think this is the only step. It makes some confusion. It will leads to you to confusion state. What I should write in the place of A productions? S productions. Okay. Okay, so I can use this production, same thing, that is 0, A0, 1, B1, BB, then 0, 0, then 1, 1. Okay. Next, B, B is also replaced with S productions, right? The same S production. So again, 0, A0, so 1, B1, BB, 0, 0, 1, 1. So then C, C is also replaced by S production. 0 is 0, 1 B1, BB, 0, 0, 1, 1. So this is the resulting grammar after removing unit productions. Okay. Then step number 3. So we have to identify the generating symbols. I think all are generating, right? So all are generating only because all productions, S gives 1100, A gives 1100, B gives 1100, C also gives 1100. So all are generating symbols. Next, you have to remove not reachable symbols. So which one I should remove? Yes, actually this is also right one for Nandini, the right question. Um, So all are produced the same productions, right? So as all are produced to the same productions, so we can remove A, B, C because these productions are also gives the same only. Okay. If I am removing A, B, C means the only remaining productions yes. So yes gives 0 is 0, 1 B 1, B B 0 0 1 1. Okay. So so in the place of A and in the place of B, what I should give in the place of A and B. So obviously those productions also removed 0, that is A, B, B, B. So finally the resulting grammar which is gives only yes gives 0, 0, 1, 1. Okay. So actually this is the exercise problem from your textbook. So what is the last, so anyone tell me what is the last production, the final production? Yes. So the final production, the minimized production which is, yes, okay. It's almost the simplification of context-free grammar, which is almost over. This problem, simplification of context-free grammar. The next problem which comes to part of the, that is the normal form, Chomsky normal form and Grebec normal form. Okay, so only the actually you can divide unit number 4 into two parts. The first part about properties of context-free grammar, like Rebec normal form, Chomsky normal form, and also it has its pumping lemma concept. Or do you mean the pumping lemma concept? Pumping lemma, which is used to prove. So yeah, we have already seen this concept in the unit number 2, pumping lemma, for proving a given language which is not regular, right? And also context-free grammar, which is also has one pumping lemma concept to prove a given language which is not context-free. Okay, so so context-free grammar, this also has its own pumping lemma concept and some closer properties of context-free grammar. These are all the first part. Okay. The second part, we just talk about pure Turing machine concept. Okay, so Turing machine. But some limited problems are there, but the problems are very big. Okay, and in the instantaneous description, instantaneous description for a Piston automata is very easy to write. But instantaneous description for a Turing machine, which is making you definitely a confusion state. Okay, that is the only difficult part I feel in the design of a Turing machine. But the problem is limited, but the problem is the procedure is very long. Okay, so this is unit number 4. So first part of unit number 4, which is over. Simplification of context-free grammar. That part is over. Next part, the normal forms, Quebec and Chomsky normal form. Okay, so I will come with some other set of problems in the next day session. Okay, so thank you, students. Thank you for your cooperation.